In this video, we will do this word problem that relates to maximizing profit in the multivariables case. So here we have a company manufactures two products. So the price function for product A is P equals 12 minus 1/2 x, where x is between 0 and 24. And for product B, Q is equal to 20 minus y, for y being between 0 and 20. So you can think of the price functions as a demand curve. So they're both in thousands of dollars, where x and y are the amounts of products x, A, and B, respectively. So let's say our cost function is 9x plus 16y minus xy plus 7. And all of this is in thousands of dollars. So we want to find three different things. We want to find the quantities, the prices of the two products that maximize profit, and then we also want to find the maximum profit. So a lot of different things here. So the one thing that you want to kind of remember is that we want to maximize profit. And in order for me to maximize profit, I just need to have profit is equal to my revenue. So all of the money coming in minus the costs. That includes variable and fixed costs. So luckily for us, we don't have to worry so much about the costs because they're already given to us. The revenue is the thing that we need to figure out. And if you remember about our revenue is given to us as the price times the quantity. So revenue equals price times quantity. So in order for us to find the revenue, notice that two things are coming in into the revenue part. Okay, the first one is the revenue for A. Okay, so the revenue for A. Okay, and the reason why I wrote X, R of X, is because if you look here, X is the amount for product A respectively. So we're trying to figure out what is going to be the revenue for A. So remember, the revenue is just going to be the price. So the price for product A is going to be 12 minus 1/2 x. So 12 minus 1/2 x. And we're going to multiply it by the quantity. Well, we don't know how much of this we're selling. That's what we want to find. So we're going to multiply this by x. Oh, I forgot the x on the other one. So this is going to be 12x minus 1/2 x squared. That's going to be my revenue for product A. And now what we want to find is the revenue for product B. So now it's going to be R of Y, because we know that product B corresponds with the letter Y. So R of Y is just going to be the price times the quantity. In this case, the price is 20 minus Y. And then I'm going to multiply it by the quantity that I'm selling or I'm producing, Y. And we don't know, so I'm just going to write Y. So I'm going to get 20Y minus y squared as my revenue for my y. So my total revenue is going to be whatever this guy is and whatever this guy is. So all I got to do is plug in both of those into my revenue function and then plug in the cost into my cost function. So let's go ahead and write profit. So remember, profit is going to be a function of two variables, x and y. My revenue is going to be all of my green part, which is this 12x minus 1/2 x squared, and then add it to my blue part. That's going to be this 20y minus y squared. And now finally, I'm going to subtract off my costs. And my cost is just this cost function. This 9x plus 16y minus, minus xy plus 7. So let me distribute out this negative. So I'm going to have the profit function, x comma y, equals 12x minus 1/2 x squared plus 20y minus y squared minus 9x minus 16y plus xy minus 7. Okay. And now what I can do is I can combine like terms. So my profit function, let me start off with my square terms. I'm just going to write them down since I can't combine those two. Negative 1/2 x squared. That's negative y squared. And now let me combine all of my x's. My x is going to be 12x and this negative 9x. That's going to give me a positive 3x. Then I'm going to look at my y values. Okay, so this 20y minus 16y is going to give me a positive 4y. Okay, and then finally we just have this random xy term and then this minus 7 at the end. Okay, now we combine like terms, and remember that what we wanted to find was we wanted to maximize this guy. We want to maximize my profit. And in order for me to maximize this profit, I require to take the partial derivatives of both. So I'm going to take the partial derivative with respect to x of the profit function and the partial derivative with respect to y of the profit function. So for the profit function, the partial derivative with respect to x, we're going to take all of my x's and I'm going to take the derivative of those guys. So you're going to have the 2's cancel out, so I have negative x. Then you're going to get a positive 3 and then a positive y equals 0. And for my y's, I'm going to go ahead and put a little thing under them. I'm going to get a negative 2y. I'm going to get a positive 4. And I'm going to get a positive x. So now let me switch some things around. So I'm going to have negative x plus y equals negative 3 by moving it over. And get positive x minus 2y equals negative 4 by moving that guy over. And notice that now I can use elimination. So I can put this one right below it, and I get negative x plus y equals negative 3. So all I'm left with is just a negative y equals a negative 7. So y equals 7. So that's what y should be in order for me to maximize my profit. Now I'm going to go ahead and plug that guy back into the other one. So you're going to get negative x plus 7 equals negative 3. Subtract the 7 over, and I get negative x equals negative 10. So x equals 10. And that guy's going to be the x value for that will maximize profit. So these are the quantities. We just figured out what my quantities were. So that's that guy. Now what we want to find is my prices. Okay, we want to find what price is. Now for product A, my price function is 12 minus 1/2 x. So for product A, my price equals 12 minus 1/2 x. And all we got to do is just plug in the 10 in there. So what should my price be? What should I put these prices at? It's going to be 12 minus 5, which is going to give me 7. Okay, so $7 is what I should charge product A. Let me just double check. Yes, 12 minus 1/2 x. And now I'm going to look at product B, and I'm going to look at the price function for that guy. I believe it was 20 minus y. And I'll get 20 minus 7. So I get 20 minus 7, that's going to give me $13. Okay, and I think this is in thousands of dollars, not $13, I believe, right? Yeah, thousands of dollars. Also, one of the things that you can look at is that x equals 10 and y equals 7 are within this region. They're within 0 and 24 and 0 and 20. Okay, so we got our prices down. Now all we want to find is the maximum profit. Since I know what x and y are now, all I got to do is just plug it into my profit function. And my profit function is this guy, right before I took the partial derivatives. This was my profit function. So what I'm going to do is I'm going to plug everything in there. So I'm going to have the profit. It's going to be by me plugging in my x values, which is going to be 10 and 7. I'm going to have negative 1/2 times 10 squared minus 7 squared plus 3 times 10 plus 4 times 7 plus 10 times 7 minus 7. Okay, so I'm going to take my calculator. I'm going to have negative 1/2, 10 squared, subtracted by 7 squared, then plus 3 times 10, plus 4 times 7, plus 10 times 7, minus 7, and I ended up getting 22. Okay, now we have to be very explicit about this because this is not $22, right? So we're going to sell 10 of X, 7 of Y. And remember, this is in thousands, okay? So this guy is $22,000 of profit. This guy is going to be $13,000 in profit. I'm sorry, not in profit, in price of B. So that's what price of B should be. This guy should be 7,000. And this is going to be price of A. Okay, so just to be very explicit, because remember that this was all given to us in thousands. So it was easier for me to plug in 13 and 7 into the formula because it's a lot easier to work with those numbers. But remember that our problem in this case says that everything is in thousands. Okay, so that's how you would do this problem. So we got everything down. We got our maximum profit already, our prices, and our quantities using partial derivatives. And one more thing, if you wanted to make sure that this is really a maximum, one thing that you can do is you can use the second derivative test, take the second derivatives, the partials, plug it into the d-test, and then see that actually this does give you a maximum.